I am refilming this mini series on graphing sine and cosine, and maybe I'll go on to the other trig functions as well. I fine-tuned this a little more as I um, gave this handout to more students. That's the perks of teaching the same thing over and over again. You just fine-tune how you teach it more and more. Okay, so let's first go over general concepts and we'll go over the parent functions sine and cosine in this video. Okay, let's begin. So let's first recall or define, if you've never learned it before, what a periodic function is. It's just a function that repeats itself. Okay, I'm on point number one right now. Periodic function, can I use a highlighter? Periodic function is a function that repeats itself. And what is the period? It's how long it takes for the function to repeat itself, how long. So you would imagine the units are in time, like for example, seconds. Okay. Frequency is how often. Okay, so you would imagine instead of in units of time, it'll be like inverse of time, like cycles in a second, repetitions per second, how often. Okay, so the units are, for example, 1/seconds, or in physics, or in lots of different applications, we say hertz instead of 1/seconds. So, like the frequency of a sound wave, we say in hertz, or the frequency of a radio wave, how AM and FM radio works. It's a carrier frequency. All right. And as I just mentioned, the period and frequency are inverses. So F is 1/t, or let me switch back to the pen, or we can say T is 1/f, same thing. They're inverses, okay? Oh, I don't want it to change to that. Why did it? I think I used the wrong pen. T is 1/f. There we go. Okay. Okay, so those are the general concepts that we need to know in terms of horizontal parameters or time-related parameters, okay? There's going to be some more for sine and cosine. We'll get to there, okay? Now, let's look at the parent function for sine of x. I'm not going to go over the table of values and actually plotting it, okay? But I marked 5 important points in one period. So 0, 0, pi/2, 1, pi, 0, 3 pi/2, -1, 2 pi, 0. Okay? All right, let me go back to the highlighter. I think that's more useful. I'm learning how to do this on the spot as well. Okay. Okay, so if we look at the horizontal parameters, like for example, what's the period? It's 2 pi. Why is that? Let's look. Well, here is the starting point. Let's say, suppose here is the starting point for one repetition, okay? Here is the next one, and then here would be the next one, or if we look backwards, here's another one, okay? Here's one period. Here's one wave, here's another, and here's another, yeah? So period is 2 pi, or frequency, you just invert it, okay? And you can see that the domain is -infinity to infinity for this guy. All right? Now I gotta switch to the pen. Let's talk about midline. Whoops, I don't want to hit that on accident. Let's talk about the midline. I need the pen now. Okay. The midline is the horizontal line that runs through the center of the wave. So here is my wave up here. So this would be like the horizontal line. Okay, it'll be actually the x-axis, but to show, I need to offset it a little bit, okay? Or, more importantly, in applications, this is the average value of the function, okay? So the midline here is y = 0. Okay, again, here is the middle of the wave. Okay? And amplitude, let me highlight midline. Amplitude is the distance from the midline to the max or the min. So what I say more casually is how much it swings up or down from the midline. Okay? So let me get back to the pen once again. So the green highlight is midline. So how much does it go up from the midline to the max? It's a value of 1. And similarly, how much does it go down to the min, the distance? So it's going to be positive. is 1 as well. So the amplitude here is 1, okay? And once we have these two parameters, we can get the range of the sinusoid. Okay, the range is just midline plus or minus the amplitude. So in this case, it's 0 plus or minus 1. So it goes from -1 to 1. Okay? All right, now let's look at what else I wrote for key observations. Okay, the important points that I marked are the minimum, the min, the middle, mid, or the max. Okay, those are usually the critical points that we need. Everything in between, that's harder to calculate, and we can get the shape just by these three critical types of points. Okay, let's kind of remember the order of sine. If we say the starting point is when x is 0, or t is 0, whatever you want to call the axis. So this point here, okay, if we call that the starting point when x is 0, so what's the pattern? It goes up to the max, down to the min, so it crosses through the mid and in between, and then back to the mid for one period. So mid, max, mid, min, mid, okay? And let's notice that each important point is separated by a quarter of a period, a fourth of a period. Okay, let's look. Let me get my pen now. The period is 2 pi. Okay, this middle point over here is just pi. So that's half the period. And this, let me scroll up a little bit. This max over here is pi over 2. And how much is pi over 2 versus 2 pi? That's a fourth. Okay, so this is the parent function, but it works for all transformed versions. That's all. Each max, mid, min are separated by a quarter of a period. Very important, okay? That's how we quickly graph the sinusoids, transformed versions, all right? Now let's look at cosine. If we do a table of values and plot the points, we would see that, well, cosine, it starts at 0, 1. It starts at the max, okay? And it repeats itself at 2 pi as well, all right? So the period is 2 pi, frequency is 1 over 2 pi, that you can easily compute. The domain is negative infinity to infinity still, no change there. Midline, where's the midline? Midline's, again, the x-axis here, y equals 0. Amplitude, how much does it swing up or down from the midline? What's the distance? It's 1. What's the distance? It's also 1. Okay, so the amplitude is 1. Okay, range, midline plus or minus the amplitude. So 0 plus or minus 1, which is -1 to 1. All right, now the order of this should be cosine. Sorry, I'll fix that. That's why I'm doing this actually. I'm pre-screening this once more. Cosine is, it starts from the max, goes down to the mid, down to the min, back up to the mid, and then back up to the max. Okay, I already said that before. Re-emphasizing it. Important to know. And again, each important point is separated by a fourth of a period. Okay, and if you notice, cosine is just sine, but shifted by a fourth of a period. This helps us as well. Okay, let me do some erasing. How did sine of x look? It started here. Can I use a different color? Hopefully you'll be able to see it. Let me try to use light blue. Sine started from the mid, went up to the max, mid, min, mid. Look like this, right? So look, if we just shift this, this is over here, minus pi over 2. If we shift it by pi over 2, which is 1/4 period, quarter period, then we get the same thing. This is actually a trig identity. All right? And typically we say that cosine is earlier than sine by the quarter period, or 90 degrees, or pi over 2 in radians. All right? Okay. I believe that should be good for this first part. Next video, we'll talk about transforms, sine and cosines, and we'll start looking at some examples, hopefully, as well.